Okay. Hi, everyone. Welcome to track one. This is attacking GraphQL. My name is Keith Makan, and I'll do the who am I slide in a second, but this is I think my third or fourth B-sides talk. I love contributing to the community, and I'm happy that everyone came to listen to this. So hopefully everyone learned something. So yeah, who am I? My name is Keith Makan. I've been in cybersecurity for about 10 to 12 years. I sort of won't be don't take my word for that. It's like around that figure. um, I'm a technical author. I've written two books, one about Android's security assessment, and one about automation. And this year I did three really difficult things. I founded a company with some folks I know from Europe. I completed my master's thesis. That's the title, and I fought in my first boxing match. Yay! So that's me. Someone's about to blow my brains out, knock my brains out. And yeah, it might be a strange leap, computers to fighting, but I think if you can get everyone to look at you and expect you to say something smart, you'll find it's easier to get someone to punch you in the face. So that's my journey with that. And in that light, I've themed all of the images you see are like me generating stuff through Google Gemini. And it's there's been no annoying graphic designers involved in any of this. I'm joking, obviously, but it's themed around boxing. It's themed around my nickname, which was Mr. Robot. I chose that because it's just closest thing to hacking that seemed fightery. Anyway, so let's get into it. GraphQL beginnings. So this talk, before I get into it, is about GraphQL. There's no intro slide to the whole topic. I just remembered. But yeah, GraphQL. I've been testing web security for around about the 10 years you see there. I've faced a lot, sort of run into a lot of different technologies, and recently I think the growth in GraphQL has been pretty interesting. Lots of different organizations have been adopting it, and a typical pen tester, I keep running into this tech, and I find there's very little open talks and people discussing how to attack it, just from my corner of the internet, I guess. So I thought it would be a good idea to give B-sides a nice proper talk about GraphQL and what you should expect and how you what are the GraphQL specific testing stuff you should look out for. So that's the spiel. Sorry, I skipped a slide there. How it started out, well, GraphQL's a Facebook idea. They were facing what apparently was some limitations around how REST APIs work. The typical stuff was, it's not really, there's nothing wrong with REST APIs. I think we've just done them to death and people are looking for something more flexible. And we'll get into exactly what was wrong with some of the limitations around REST and why it came to be. But the basic story of GraphQL is, just about 10 years ago. We started developing it. 2015, they released it. And in 2018, 2019 is when they established the GraphQL Linux Foundation, under the Linux Foundation. And it's obviously like an event that shows how much public community is sort of grown around the tool. And there's no real 2024 point. It just makes the slide look a little bit more rounded to say it's continued and it's been good. So yeah, adoption. This is their stack page for GraphQL. Very quick reference. Very big names. They make a lot of money. They build a lot of important stuff, and they've been adopting GraphQL quite aggressively. We'll look at why in a second. Why GraphQL? Also another cool piece of art. Why GraphQL? Well, firstly, we'll see in a second how the query format works, but it allows flexible agglutination and summarization of queries without changing a profound amount about the backend. So you can slap things onto queries and take them on, and the same front end will handle everything. There's also a very flexible query language, so you can ask for a lot, you can ask for a little, whatever you need. Kind of the same point as the previous one. But the other thing that's really good is the strong data typing right from the beginning. GraphQL requires you to declare which types go into your typing. You actually design a typing system for GraphQL, and the runtime handles how that ends up in resolving into actual web traffic and queries to your backend. So the good thing about that query language, which is a bit complex to get your head around at first, is it bakes in the types. So there's no stuff like PHP where you can pass a string off and get it to be treated as an int or the other way around. It expects you to if you give it a string, it'll be treated like a string. If you give it an int, it'll follow right through, depending on how you implement it on the back end. But the runtime keeps it pretty strict. And then also rapid API evolution, because you have one endpoint that's representing a lot of possible transaction. You can scale your backend and the front end can stay the same. You can rapidly change what's going on behind the endpoint, and the query language and the implementation and the roots don't need to change a profound amount. And then also, because it's Facebook, you've got a lot of developer mindshare. They've got communities around building the product, so there'll be a lot of support and a lot of exciting stuff happening. So yeah, let's get into the anatomy of GraphQL. I'm really proud of this one, by the way. Lots of detail, exactly what I wanted. Nice. You could make a whole game with this tech. I say that because, like, growing up, there was all these RPG game makers. I'm sure you guys know that. And the most annoying part was like getting sprites that you actually wanted. So now that problem solved, I'm going to be making games for the rest of my life. So yeah, anatomy of GraphQL. Also the icons, LLMs as well, very consistent. Metal slug X, that's the keyword. So yeah, typical setup of a GraphQL application is you have the client side and the server side, and depending on which approach you take, your middleware might be part of your GraphQL server. It might be something you slap on or work around it. And then the other moving parts to this conversation are the resolvers, the logic, and the storage. The logic and the storage are the pluggable parts. So you can have PostgreSQL, a bunch of other storages that you work in, and the logic is the stuff that once you've decided what you want to ask for, how do you get that back to the middleware, basically. So that's where you write, like, give them a hello world page, look up their IDs or whatever, and the resolver part is what takes your type system and splits it into resolvable logic. So yeah, the one thing you need to get your head around with GraphQL is the schema, and the stuff I've written in bold is the basic requirement for a schema. It just needs a query, that's the root type, and the other stuff you can add on. There's queries, there's subscription types, and mutation types, and you can think of queries as get me stuff, even though that's not like, it doesn't have to only be retrieval. You can do mutation with queries if you really want, but the idea is that mutations are kind of like your post requests that send payloads and change stuff, and the queries are retrieval. They take payloads, but they don't modify state. That's the guidance. And just an example, I've expanded the type query here to some CVE specific stuff. So for an example, you could have queries that are like get CVE title, get score, and for example, a mutation would be put CVE ref, like if you want to add a link to CVE, supposedly. And I didn't flesh this out a lot, but it has basic types, obviously, like any other typing system. So it has strings, ints, floats, IDs, and booleans. There's also enums and lists, which I didn't mention here, a little bit more complex than a basic type. But you can use these to build more complex types. So if you wanted to make a CVE ref, for instance, you'd use a string to represent the URL, maybe an int amount of counts or hits or whatever. You can be very creative with the type system. It's fully expressible. People have been building lots of complex and cool stuff with it. And a simple query exchange looks like this. You have all your post headers. This is taken straight from there's lots of playgrounds online where you can try stuff. People are hosting this just so you can test out the technology. So this is typical HTTP stuff. The only weird thing about this is the JSON at the bottom, and it holds your query. This isn't the cleanest query, by the way. It's a introspection query. It's a little complex. I'm not going to totally unpack it, but the basic thing is you have a query sort of JSON-ish object in the array. I keep showing with my hands, but you're not looking at my hands. So there's a query type, and inside that's the questions you want to ask. So if I had to walk through this query, it'd be, hey, give me information about a type. The name is asset, and what I want to know about this type is the name. And the fields. So for each field, I'd like the name, the description, and the type of the field. And that's the way the conversation works. Every time you want to add to the conversation, you nest another question or you slap it onto a list. That's how it works. And this is where you get the whole idea of precise fetching. There's no under or over fetching. You ask for what you get and you get exactly that. Versus a REST endpoint where you ask for a thing, you get only those things back. There's no variability. You have to cache everything you get, whether you need it cached or not. So yeah. a little bit more flexible. And then some of the, I think the big things that I, as a non-everyday GraphQL developer, noticed is one of the more common offerings is things like Apollo. Node.js has Express GraphQL, which used to be Express GraphQL on its own. It's now not maintained on its own. I believe it's part of some NPM package. Then there's Hasura and PostGraphQL. I think if I'm saying that right. But yeah, PostGraphQL allows you to, let me try to adjust this. PostgreSQL allows you to generate GraphQL APIs straight from PostgreSQL databases. And this is a brilliant idea because a lot of people obviously dredge around the whole concept of generating a schema to use this thing. It's like, why do we have to learn this new language? So if you can speak PostgreSQL, you can migrate to GraphQL pretty easily using this tech. And then why would you use each one? This is just a spiel. I think all of them are probably great. I'm not here to argue about sort of these minutiae. But Apollo is great because it's big, it's branded, it's well supported, it's got a large community and tons of documentation. You basically can't get it wrong. Node.js, lots of other things. The great thing about GraphQL's Node.js's GraphQL is that it uses the same HTTP engine as Node.js, obviously, and that a lot of people love that. Hasura does some AI stuff, not an expert on Hasura, and I mentioned why PostgreSQL was cool. So let's look at some attack patterns. Ooh. Very interesting thing that's wrong with this. You guys will notice that the reflection doesn't work. So LLMs are great at making pictures, but reflecting is not that. Right? So one would say that that's almost more authentic or intelligence, given what's going on today. We're good at describing things, but not good at reflecting on them. So yeah, GraphQL specific attack patterns. So the first slide is just, you get all the basic stuff. Like this is, and at the end of the day, just a delivery mechanism. All the poison can still be inside. It doesn't change that. So you can still have SQLi, you can still have SQL, XPath, XSS, all the good stuff, CSRF. I'll talk about CSRF specifically because there's the nature of the transaction mechanism means that there's only certain ways that this is going to be possible due to the way people commonly defend against CSRF. But we also talk about the last four, which is very specific to GraphQL: introspection, disclosure, batching and nesting, overloading aliases, and circular queries. I'm not going to spoil the party too much, but yeah, let's talk about CSRF. Firstly, if you want to see if the CSRF on a GraphQL thing, the reality of it is that you're going to be exchanging JSON objects the whole time. And the only time it's possible to CSRF, first of all, do I need to explain what CSRF is? Yes, no. I'll just go over it real quick. Cross-site request forgery. One browser origin is allowed to send requests to another browser origin on behalf of the user, not always with their consent or awareness. So that's cross-site request forgery. The way that we prevent this in GraphQL is usually by making sure that the server doesn't accept anything except application JSON content types. And the reason for that is because if you allow other content types, you can contrive a form submission that will sort of have enough structure in it to be interpreted as JSON while not actually being full JSON. So there's too much variability around the JSON subtype so that if it's not strict, you can probably do CSRF very easily. And if you can't do, if you are accepting, so I didn't label the stuff, but the top one is no and the bottom one is yes. So top is no, we don't have content type freeness. So we then have to rely on cause. So like you have to hope that the same origin policy is relaxed in some way that it allows you to send a request on behalf of the user. This is the top route. The bottom route is yes, you can do application, you can submit data types other than application JSON, and that just means like you look for a form to redirect, to inject, you try to fire off the request, and Bob's your uncle. So pretty simple there. The other thing that's unique, so the first thing we're talking about that's unique to GraphQL is something called introspection. And this is like a sort of self-documenting function that APIs have. It's basically a special question you ask an endpoint, and it returns a description of the schema that it uses to format data. And it's a little bit. This is a bug that tends to be a little bit flaky to report, depending on the context. It's a heavily contextualized bug, because many people, when they report this stuff, it's intentional. The documentation is intentional. It's usually built in, and it's okay to discover the schema. But there are times when this is just left on, and you're sort of slapping in a lot of functionality, and you forget that people can look up your schema, and you might include things in there that's not too great to publish. Two examples I found is CVE 2024 6861, and this is they literally had authentication keys in the schema that was being disclosed. I don't know how that happened really, but it's great that there's a documented example where this goes wrong, so developers don't argue with me that much. So yeah, those are two examples, and this is what an introspection query looked like. I kind of leaked it in the previous slide. You basically have these special queries, keyworded queries that start with underscore stuff. I'm not going to be too technical about this just yet, but the underscore name means it's an introspection query. It returns documentation about a type, and inside that field you can say, from the schema I want the query type, maybe I want the mutation types, and of those I want the names, the fields, and you're just discovering more and more of the graph basically. And this is what the return looks like. It'll return a sort of JSON object of schema and type query and names, and then this is a sort of more full example, I guess. So here you have an introspection query that was added by the playground itself. So it's gonna have like casing that's not 100% consistent with burp stuff. That's why it looks a bit different. And you can see it returning the query. It says, hey, there's a query type, there's a mutation type, and here are the types that are embedded there. They have something called aggregate. There's also a description field, which you shouldn't forget about, because it might have very verbose information about what's going on. But that's the basic thing. The other interesting keywords to try to do introspection with is obviously type name, kind name, field name. I always burp the most when I have to give talks, sorry. And the rest of the cool stuff. And this is for burp. I believe they just added this, which is really cool. You can right click and just say set an introspection query, and it dumps a whole introspection query straight into your post request. And Bob's your uncle. You can get that done. The other way to exploit introspection is to use InQL, which is a burp extension you can install very easily. And basically you just send this to InQL, and then it'll dump the whole schema. And one of these files, I don't know if there's a mouse. So at the bottom of these files, there's a thing called schema.json. It holds the whole schema. Once you pull that out, you can take that over to something called GraphQL Voyager, which is like, it basically just takes the result of your introspection query, and it produces a cool graph that looks like that. And this is the worst way possible to document a graph, but forgive the technology. This is the place where it is. But assumedly, you'd have small enough schemas that this would be useful to you in some way. The point of this is that you can look at it and figure out whether there's circular dependencies, whether there's things that are unnecessary, redundant, things you don't know, or connections you don't know. It's a lot of fun to look at it. This image took a long time to generate because it was very messy, but it came out really nice. You can actually see the icing on the cookies, right? So the other thing, so we talked about introspection. Introspection allows you to learn, abuse documentation potentially to extract things that are not meant to be so openly documented. The other common attack pattern is batching and nesting queries. So the flip side of having this precise querying, agglutination and omission stuff is that you can also overload queries a lot and cause denial of service stuff. So batching is when you add a lot of queries of the same type and you get the API to honor them in such a way that it scales resource consumption in an uncontrollable way. And the other interesting angle to think about batching is if this invokes the infrastructure in such a way that components are moving in parallel to honor a request, then you might be able to batch in a race condition, depending on how that works. I don't think anyone's done that in public research, but that's a cool idea. And obviously, batching and nesting means you can brute force in interesting ways. You can get it to honor guesses for, let's say, authentication, and you can pack in like 100 guesses per request, which is way different if it doesn't honor those, right? Like, so for instance, I don't know if this is making sense, but some GraphQL queries allow you to log in through the query. And that means if you can batch the query, you can brute force the login. The other thing is nesting. We'll see an example of this. Nesting just means you embed queries infinitum so that it has to relook up these values the whole time. And batching queries is pretty straightforward. So it looks like this. You take a query and you stick in a whole bunch of questions and see if it answers everything. I don't know if there's a better example than this. Pretty straightforward. You don't need a big IQ to understand why that would cause a problem. Lots of queries, lots of compute, lots of problems. And then the other one is nesting and circular queries. I unfortunately didn't flesh out an example of circular queries, but I did show you a schema, and it does make sense why that would emerge. You could have one type that, so this is a good example, I think, sorry, this is nesting. This is circular, not nesting. It's circular because you can look up the authors, and the authors in the schema allows you to look up the posts, and the posts allow you to look up the authors. So you can just rinse and repeat this lookup to make like a massive request. And if the person who developed the resolver wasn't smart enough to defend against this, it means that every time you pull an author, it's got to pull a whole memory author object out of memory for every single time you perform the query, which would be the resource cost would scale exponentially really fast. And this is alias overloading. So the other thing you can do is you can slap an alias or a keyword onto a query. And the reason you'd want to do that is because the engines that receive the query might be smart enough to cache the query that you send. So if you send the same one the whole time, you're just going to hit the cache. One way to get around that is to add an alias. So you can say alias leet, this is my question, alias 1, this is my question, alias 2, this is my question, boom, 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 boom. You can stack up a lot of queries for the same thing, and the engine will treat it as a unique query. So yeah, that was pretty much the most exciting things to talk about thus far about GraphQL. I hope I had enough fancy things to say. This is a list of the tools I've looked into that I think are competent enough. The problem with GraphQL tools is that they're not very stable and they don't receive a lot of love for a long time. So the stuff you run into will probably work for a little bit, but you'll see, like for instance, Graph Finder, which is made by the folks at Escape, was quite a prominent tool a year and a half ago but they stopped developing it completely, and I think they funneled all of their developer effort into the paid service that they offer now. So GraphFinder is cool, but doesn't receive any love lately, so it's a little bit weird to trust it on your pen tests. GraphQL Cop's pretty nice. I think it's really good tool. It's a really good tool for quickly figuring out whether there's whether aliasing is allowed, circular queries, or batching is allowed. It just spits that out immediately. So this is nice and scalable. And if you wanted to make an automated tool around GraphQL Cop is a really good contender. And then I think the paid service that people talk a lot about is escape.tech. You just pay them a bunch of money, they scan it, and they handle the problem yourself. If you're in an organization that can do that, I think it's a good tool. But yeah, so far I've been having fun with the scripting stuff. So defenses, I think, are pretty straightforward. You can implement them at the mid. I mean, this is the interesting thing because some middleware rate limiting protection will not protect against some of these attacks, right? Like you can send one request, the rate limiting will allow it, but the backend will be producing a lot more noise. So sometimes traditional rate limiting will help you, but I think the best defense is to make sure that your specific implementation, you're aware of the depth limitations and the size limitations on queries. All the engines have responded to this. Some of them have built-in responses. But yeah, if you're going to deploy GraphQL, please make sure you don't open yourself to denial of service attacks. And of course, the other point is deploy a firewall and get folks like me to look at your stuff regularly. So yeah. And again, the last slide, I thought was a good thing to mention is some of the stuff we're missing in the GraphQL toolset is better fuzzing capability. So like, I think I see a lot of stuff where people can extract schemas and build requests for you, but no one's doing really intelligent fuzzing of a schema. Like if I give you a schema, can you produce arbitrary sentences in this language ad infinitum? Like this is a good way to test how you're parsing and handling queries. The other thing is better automated exploitation. So we have SQL map for SQL stuff, but I don't see a strong equivalent to GraphQL unless I'm missing something. So something where I can just push a button, it collects all the data and has optionality around the different exploitation capabilities. Particularly switching between, like if I have a GraphQL and I enumerate all the stuff and I find a SQL injection bug, what do I do with that? Like there's nothing where I can exploit the synergy between these two, as far as I know. So yeah, and that's it. Thanks for listening.
Across the attack surface, scattered products and siloed views create blind spots that feel unstoppable. The deadliest risks are in these gaps, where attackers move in. It's time to unify fragmented snapshots into one all-seeing view of risk and unleash a platform born with one intention: isolate and eradicate your priority exposures. From IT infrastructure to cloud environments to critical infrastructure and everywhere in between. This is Tenable. Your exposure ends here.